Okay, welcome back again to the next video in chapter 2. Okay, so the last concept I want to look at is that, in fact, let me say this, there's something that I've taken out in chapter 2. Not taken out, but I believe that maybe the time will not allow me to do also. As time goes, I'll be taking few things out. But not to lose, so the quality of the course will be there. It's dot product and application of dot products in mechanics, but we're not going to go out. So what I want to look at is position vectors. Okay, I believe some of you know position vectors to be, let's say you're on the x, y plane, and this is the origin O. So if you have a point A here, and you join it as a vector, then we can say vector OA. Another way of saying it is as the position vector of A. So we can have position vector of B. So like this, vector OB, things like that. Okay, and so on and so forth. And no, in some area they will say if you have A to B, that is you go from A to B like this. Then we can talk about vector AB. People like to call this one like relative. These are position vectors. And people like to call this like kind of relative vector. Okay, or is the vector B relative to A, or the displacement AB. Of course, this is also displacement OA, displacement OB, and so on and so forth. Now, some people like to use the symbol R like this to represent position vector. So the textbook uses that. So position vector OA, position vector OB, things like that. But you can still stick to what you used to know. Just write OA, OB, and so on. I mean, it's fine. Okay, it's fine. Okay, of course, if you're in 2D, then it's just XI, YJ. If you're in 3D, XI, YJ, and then ZK. Okay, now let's do something quick here. Point something to out to you. Oh, I think I raised that diagram. That could have been easy to explain. I mean, this is X, and that is Y. And I had a point B here, and I have a point A here. And I join this. This is point O. And I join that. And I went to, was it AB? Yeah, let's do AB. If you follow the triangle, this is like a triangle. Yeah, triangle OAB. If you follow the vectors, you're going to see that if you want to go from, assume this is, best to put this. Assume this is O is Legon campus, and this is Tetekwashi, and that is Tema. Maybe there's a route to go from Legon to Tema directly, or you have to go to Tetekwashi before you go there. So what it means is that going from Legon to Tetekwashi roundabout, that's where the Accra Mall is, and then going here is the same as going to Tema directly. Okay, so we said OA plus AB is equal to OB. So if you look at this very well, we're going to see the AB, that's a relative vector AB, is equal to OB minus OA. Okay, these are important results that I want you to know, and we're going to use that. Okay, and there's a trend to it. So look at the trend. If you want to find any vector without making a diagram, AB, then you do O. We can relate we can write relative vectors in terms of position vectors. That's what we've done here. Relative vector AB in terms of position vector of B and A. So look how it goes. You want to find AB is O to B first, O to the second one, minus O to the first one. Okay, let me write another one. If I want to do PQ, then PQ is O to the second one, which is Q, minus O to the first one, OP. And take note, vector AB is negative BA, or vice versa. BA is negative AB. but they have the same, what do you call it, magnitude. They have the same magnitude. So let me write one more time. Vector Mn is O to N, O to this one minus O to the second one. That, okay, cool. If you are using the test will write this as R Mn or something equal to R O N minus R O M. But we don't worry, we can leave out this. So that's how to express relative vectors as position vectors. That's how to express it. Very, very, very easy. Very, very easy. So that those are the things that I've done here. And let me take this off and write something. So when you were in high school, possibly you say, oh, if you have a point A to be 2, 4, and I have a point B to be minus 6, let's say 10, and you want to find vector AB, let me write what you should do, the column 1. Then this is OB minus OA. So then you write this as, take note, these are coordinates, they are not vectors, they are coordinates. So the vector OB is in column form is minus 6, 10. And then this is 2, 4. So if you do the subtraction, minus 6 minus 2 is minus 8. Minus 10 minus 4 is, sorry, 10 minus 4 is 6. Okay. So if these are meters, coordinate meters, then the vector AB is also meters. That's how to work that. And you can also work in Cartesian. In Cartesian vector form, you say AB minus OB. AB is equal to, sorry, AB is equal to OB minus OA. And then you write each of them in IJ form. So OB in IJ form is minus 6I. And that's what we're doing in this class, plus 10J. And then for OA is 2I plus 4J. And then you do the subtraction, and then you get minus 8I plus what? 6J and in meters. So you can work with column form I, but here we are working the IG form, Cartesian. You can do the same thing, you can extend it to the 3D. So you have an IJ and then the K. Okay, so those are position vectors. Okay, and that's what I've done here. Whether you're using the R's after AB or you just say AB, and you're subtracting the two numbers, the X value of the first one minus the X value of the X value of B minus that Y value of that. But we're going to work with numbers. So let's do this example quick. Let me switch to do example 12. We'll do example 13 and then we'll do 14. So let's have this structure, and then this is a cable that is supporting it. And let's do some step by step here. The first one is A. What is OA? So this is O here to A, and that is the X direction, that is the Y, and that is the Z. I told you the X and Y, Z, I can flip them around. It doesn't matter. You have to follow accordingly. So what is OA? OA, based on the picture, is just go from it. That is here we are doing displacement. These are displacement vectors. Okay, these are displacement vectors. So the distance from here to here is 80 meters, and that is the Z direction. So if you are old A, you are going the positive Z. So that will be what? 80 K. Let me put this one then in meters. The same way to, if you want to do OB, OB is going from O to B. So as you could see, you have to go this way first before we go that way. Okay, and we are looking for this. So we go this way. This way is in the Y direction, positive, and this way is negative X, and we write them in order. So the X comes before the Y. So we have negative 30I, and then we add 40J. This distance from here to here is 40, as you can see, and the distance from here to here is 30. But you go 40 in the y positive, and then 30 in the x negative. Okay, this is also in meters. Then they want you to find AB. Okay, they want you to find AB. So to find AB, as we said before, then you can undo it this as OB minus OA. And this will be called to OB is minus 30 I plus 40 J. Then minus your 80 K. Okay, then it becomes one line. Minus 30 I plus 40 J minus 80 K, 8 meters. Okay, cool. You don't even need to do it. If you are given the picture, later on, I'll do an example. I'm going to show you what to do. If you want to find AB, it means you are going from A to B, and you can follow this directly. So for now, let's just do that. Then B, you say find the length of the cable from A to B, the length. So here the length is the distance. The length is the distance. So the distance of a displacement is the magnitude. Yeah. And the magnitude, let me put it in a better way. The magnitude of displacement is the distance. Okay, so you need a distance. That's what they're asking to do in B. So we want to get a length. Length AB. That length of the cable is given like this. Okay, and that'll be square root of minus 30 square plus 40 square plus minus 80 square. Okay, minus 80 square. Very, very, very easy problem to look at. Very, very easy problem to look at. Okay, I need to get a calculator and work this out for you. Okay, so hold on, let me get a calculator. So this is 30 square plus 40 square plus 80 square. And if we work this out, I'm getting 10 root 89. So let's leave it like this in also in meters. That'll be the length of the cable. So look, this cable might be very long, but the engineer, you don't need to climb it and go and use some measuring things. No, just knowing this and this and knowing the length of that, we can easily work out the length, how much cable we need. See, we can easily work out how much cable we need. And last but not the least is the direction of the cable from A, going from A to B, going from A to B. Okay, so it means the direction. How do you express the direction of in 3D? Either you can use the direction cosines or you can use the coordinate direction angles, the alpha, beta, gamma. Okay, so I don't know whether to work this out, but okay. So let me just use, so as engineer, you have to express in some form. So you have to find cosine alpha, or you can find the alpha itself if that's what you want. Okay, and then you find cosine beta, or you can find the beta itself, and then you find cos gamma or cosine gamma, or you can find the gamma yourself if that's what you want. So what is cos alpha? Okay, the alpha part, you use that is minus 30 here over the magnitude, which is 10 root 89. And I can tell this angle, if you work it, that will be obtuse. And the next one will be 40. As you could see here, you take it from here. So I'm picking these numbers. 40 over 10 root 89. And the last but not the least is minus 80 over 10 root 89. Okay, so they didn't tell you, so you can leave the answer as the direction cosine. The direction cosines are the cos alpha, cosine beta, and cosine gamma. Okay, and some places you like to also work the alpha, beta, the angles themselves. Okay, so that is respect to this question. We've done that. The same question, I'm going to look at the same question in example 13. Okay, in example 13, you say if the tension in the cable AB is the same problem I solved. Then let me see whether I did something here. If the tension, determine the force acting at A, determine the force acting. I don't know whether, or possibly, okay, that's fine. Okay, understand. Okay, the question is correct. Okay, so we know the displacement AB. This is actually not AB, this is the tension. So the tension is the force. So there's a tension in the cable. The one I computed was the displacement. Okay, determine the force acting at A towards or at B. Determine the force. In other words, this is the magnitude, and we want the force in IJK form. So what will you do? So the force, remember, is always the unit vector in the direction of the force. Or let me write it. What? It's always the magnitude of the force times the unit vector in the direction of the force. Call it that way. So what is the unit vector in the direction of the force? Yes, here we don't know that, but what we know is we know this is the same as the unit vector in the direction of AB. Yes, it's the same as the AB. Well, we know the displacement AB, so we can be able to find the unit vector, and then we know the magnitude to be of the force to 20 root 89, so we can work that. Don't we know? So this we are following from the from example 12. This is a continuation of example 12. For example 12, we had AB to be this. And let me even show how to write AB directly instead of doing OB minus OA. You don't need to do that because you have the picture, and that's what we're going to do. So look the way to do it. You are going from A to B. So look, I have to walk. I'm going to walk down like this, down in the Z. So I'm coming down 80. So that is negative 80 in the Z. Then I'll go this way. That is 40 in the Y. Then I'll go this way. And that is 30. Okay, so you don't even need to do this from example 12. You can do it directly here as well. So let me take this off. Let me take this off. So AB, based on the picture by inspection, is 30, which is negative 30 in the I, plus 40 J, and negative 80 in the K. And this is in meters. That's the displacement. That's the displacement. So you don't really need to waste time if you have the picture. Unless you have the coordinate, then you can do OB minus OA. Else, what you do is just follow the arrow. I'm going to do the same example in example 14. I'm going to do the same thing in example 14. So you come down like this, come this way, and then make sure you write them in order. X followed by Y followed by Z, and then that. So what is the unit vector? The unit vector in the direction of AB is equal to what? The vector AB over 8 magnitude. Take note. Take note, over 8 magnitude. So this is going to be minus 30 I plus 40 J minus 80 K over square root of minus 30 square plus 40 square plus minus 80. I can put some brackets here. Minus 80 square. Okay. We already done this already. So so it's minus 30 I plus 40 J minus 80 K. And I had this to be, if you remember the next slide, it was 10 root 89. So this was square root of 10. 10 root 89. Okay. So therefore, what is the force F in IJK? The force F in IJK is equal to, I'll do this in a better way in the next example. It's equal to square root of 20 root 89. What is the tension The tension is the magnitude, isn't it? The tension, that is the magnitude of F, is 20 root 89 in newtons. Okay, times the unit vector. So take note about this trend. And I didn't need to write everything. I could have gone directly and written this. So this is minus 30 I plus 40 J minus 80 K over 10 root 89. So I intentionally picked them so that the root 89 will cancel, and I intentionally did this example. So this will end up nicely to become root 89 cancel root 89. 10 goes into 20 twice, and then you use 2 to multiply all this. If you do that, you're going to get minus 60I plus 80J, and then minus, I think, 160K. And then we're done. And then newtons. So that is the force in the cable in IJK form. In IJK form. Take note. So I'm going to do the last example, and then I'll finish the chapter. Okay. I think I've already explained. We've already explained this already, so we don't need to go through. I've done this already. That every vector, or in this case force, can be written as its magnitude times the unit vector in that direction. So if the line there is AB, you multiply. And I'll show how to get AB. AB is OB minus OA. But if you have the picture, you don't need to do OB minus OA, you just use the picture. So I'll do this last example. Oh, I was supposed to do this. Okay, that's fine. I'll do this last example, and then we're done. So yeah, you have given two. So I'm switching to the one note, and that's example 14, and then I'm done. Please, I'm going to make, if you look at the textbook for this solution, a couple of steps have written, which is fine. You can do that the same thing. But I'm going to do this in a very compact way, and I want you to get used to that. Very, very compact. Few steps and I'm done. So watch it. I have two forces. Okay. Two forces. It's as a result of the tension. There's two cables. One cable is from A to B. The other one is from A to C. And they are holding. You see, there's a hook here. And they are holding this structure. Okay. This structure is kind of some plate. They are holding it. So as engineer, what you'll be interested in is you want to know the resultant of these two tensions or forces. The magnitude in this one is 100 newtons. The magnitude in this one is 120 newtons. And want to know the resultant. We can get a resultant in IJK. They didn't ask us to find magnitude and direction, so I'm not going to do that. We just find in IJK and we just leave it. So the first thing is to express each of the forces in IJK. Take note. The first thing is just express in IJK, and we just add them, and we are done. Okay. So note. Okay, it's not part of the solution, but note that every force is its magnitude times the unit vector in the direction of the force. Okay, note. It's not part of your, but note. That's what I'm going to do. So the first force is written as FAB, vector. And this is what? Its magnitude, which is given as 100. I'm making this compact. I don't need to write any formula. And look what I'm going to do here. I'll show you. This is compact. Very, very compact. So this is the force F, magnitude 100 times the unit vector. What is unit vector? The unit vector here is, we are using the displacement. So it is displacement over its magnitude. The displacement over its magnitude. So let's go from A to B. Watch carefully. A to B is lying in the ZX plane. It does not have a Y component. So let me go. To go from A to B, either I come down like this, and I'll go this way. That is one way. Or I can also do like that. But let's follow that. So coming down means I'm going down in the Z direction. And that is by 4. So negative 4. And then going this way, I'm going 4 in the positive X. So I'll write this as 4I minus 4K. And that's the displacement. That is the displacement. So if you didn't get that, I'm using FAB, that equal to magnitude of FAB times the displacement, the unit vector in that direction, and I'm using this. That's exactly what I'm doing. And this will end up to be over 4 square plus minus 4 square. Neatly done. Neatly done. And then let's write the answer. So 2 steps to express the forces. Let me see this one. Square root of 4 square plus 4 square is 4 root 2. Okay, 4 root 2. So I don't know, 4 root 2. This is 4 root 2. The 4 goes into 125. Okay, so if I want to do 100 divided by my answer, okay, it's coming out to be I don't know. Normally, okay, let me write this. This is like 25 root 2 over 2, all times 4I minus 4K. Some of you can express in decimal. Okay, so we can write this as the 2 goes here. So easily we can write this as root 2. 2 goes here, 2 goes here 2 times. That's like 50I minus 50K. You can do something like that, no problem. Or you can write in decimal anyhow you want to do it. Or you can leave it as this was what was it? 4 root 2. So you can take the 4 to goes into 125. So you write 25 over 2, and then you cancel it. Let me see. Square root of 4 square plus 4 square. Yes, so but it's going to be 1 over root 2. So that, okay, cool. Let's go on. Then I'll go to the next one. The next one is FAC. They didn't say F1, F2. We are just using what is there. So FAC. So look at it. To go from A to C, once again, I'm going to come down, come this way, and then come that way. Or you can come down, go this way, and then go that way. So negative in the Z, positive in the Y, and positive in the X. In the Y, I'm moving 2 meters. In the X, I'm moving 4 meters. And the Z, I move that. But this is negative. That is positive. That is positive. Okay, so let's do that. So this is the magnitude of FAC is 120. So 120 times, and maybe I didn't write this, but this is AB over its magnitude. So that's exactly what I did here. The displacement AB over 8 magnitude. And that's the way I want you to do it. Don't waste too much time doing OB minus OA and all that. That's waste of time. So here we're going to still have 4I plus 2J minus 4K. Let me see whether I wrote it well. Let's see whether I wrote this thing well. So 4I, 2J, and then minus 4K. I believe it's correct. And this will be square root of 4 square plus 2 square plus minus 4 square. And then you do that. So let me do square root of 4 square plus 2 square. Normally it will give you nice numbers so that you can easily take the square root and get a whole number. Yes. So I'm getting 6. I'm getting 6 for this. Yeah, square root of this will be square root of 36, which is 6. And 6 goes into 12 twice, so that will be 20. So 20 times that is it 80 I plus 20 times that will be 40 J, and 20 times that will be 80 K. Okay, and the unit is in newtons. This is newtons, so I didn't write. This is also newtons. Okay, newtons and then newtons, and then we're going to just add them. Just going to just what add them. Okay, so the resultant. Okay, so let's see this is the resultant. Therefore, the resultant force I think I've been using FR. It's my FA, okay, my FAB vector at my FAC vector. So you put things here. The other one was, I believe it was, what is it, root 2, 50I minus 50K at 80I plus 40J minus 80K. And this is equal to, so at this point you can work it out and then write the answer in decimals, no problem. Okay, because this is 50 root 2, then you add it to that. If you do it, let me just write the answer for the test. This is around about let me see, 50, 80 plus 50 root 2. Change it. This is about 150. Let me write about one decimal place, 7I. And then they ask for the J, there's no J, so the J is the same as this, that'll be 40J. Then minus, okay, then minus. So we have 50 root 2, which is negative, and then negative 80. This will give us about the same number like this, but negative 150.7 K. And then this is the answer is Newton. And that is a resultant. That is a resultant. We can go ahead and get the, even though it's not part of it, they didn't ask you, so don't do that. You can get a magnitude of FR. You can get the alpha, beta, gamma to represent the direction. But they didn't access, so they just find a resultant. So we just stop here. And this brings us to the end of chapter 2. But I've shown you something here which I want you to stick to, which is this thing that I did here, this thing, and then that 2 steps. I do not want you to waste too much time writing what is OB. You're going to see this done in the textbook, but I don't want you to do that. 2 steps. You take the magnitude, multiply by the unit vector. The unit vector is the displacement over its magnitude. Then you write the answer down. Finish in decimal or exact form. Then you come the same thing. And sometimes I'll give you nice numbers so that when you take the magnitude, you can easily cancel. So magnitude times the unit vector. So displacement over its magnitude answer, then you can continue. Okay, so this brings us to the end of my this video, and that's the end of chapter 2. And thank you. Maybe I will start recording chapter 3 as well, or maybe we'll do that on Tuesday. Thank you, and bye-bye.